Hey guys, this side Diya Makhija from Bible classes, and today I'll be taking up one of the chapters of science from class 9. So let's give it a start. The topic that I've chosen is motion, which is one of the chapters of physics from your science textbook. So whenever we see or hear anything new, what is the first thing that comes to our mind? That what is it? So the same question I'll be discussing, what motion actually means. So let me relate it to one of the most commonly used terms in our language, movement. Every one of us must have heard this term, movement. So let me relate this term movement to motion. Anything that shows movement is said to be in motion. Clear? Anything that shows movement is said to be in motion, or simply anything that moves is said to be in motion. If we have observed things around us, movement of birds, flowing of water from the tap, the most easier one, the air that we breathe, water flowing into various water bodies, the waterfalls, and different means of transport as well. Flying of an aeroplane, movement of train, movement of buses on the roads, movement of cars, and all those means of transport, anything that simply moves or changes position is said to be in motion. Now, as I mentioned that anything that moves is said to be in motion, then what is the main point of difference between these two terms? Anything which is said to be in movement means that it is changing position in relation to a reference point or fixed point. Now I mentioned a term, reference point or a fixed point. Now whenever you see anything moving, supposedly this is a street, there are some trees and a car is moving. Okay, so what will tell you that this car is moving? These trees are stationary objects, they will not change their positions. Okay, so these can be our reference points. These can be our reference points or fixed points. So with respect to these reference points, supposedly my car is at position 1. Now after some time it is at position 2. So trees are the stationary objects, they cannot move, but this car is moving. So for sure this car has changed its position from 1 to 2. That means this car has shown a movement. Now if this was movement, then what is motion? There is one basic difference between movement and motion. Movement is the change of position of an object in relation to a reference point or fixed point, whereas motion is, in physics, motion is termed as change of location of an object with respect to time. Mind my words. What did I mention? With respect to time. That suppose at time t1, if an object was here, then in reference to a fixed point and with respect to this time, if an object is changing its location or position, then it is said to be in motion. Okay, so simply motion can be defined as change of position of an object with respect to time. So what was the point of difference between the two terms, movement and motion? In movement, we simply see the change in the position of an object with respect to this reference point, but in case of motion, we notice the time as well. Okay. Now, I mentioned a point which was a term which was reference point, which is also known as stationary point, and it is a fixed point. That means it will not change its position with respect to time because it is a stationary point, a stationary object, or my point of reference. So let's consider this image. In this image, we can see a road and side by trees. Let's take these trees as point of reference. Why did I take these trees as point of reference? Because they will not change their positions with respect to time. They will be at the same place as they were in the past. So let us consider that this cyclist is cycling a bicycle on this road and he was at somewhere at this point at time t1. Okay, cyclist c1 is at this point at time t1, and with the passage of time he has reached somewhere over here. Okay, so my point of reference is this tree and this tree. These two trees are stationary objects. They will not change their positions with respect to time, so they are my point of references. Now this cyclist was at this position at time t1, and with the passage of time he has reached to a location which is parallel to this p2, that is my second point of reference. That means the point of references are stationary. They are not changing their positions. What does this conclude? That this cyclist is changing his position from this P1 to this P2. That means he has changed his position, he has changed his location. So what is the conclusion? That anything or any object which changes its position with respect to time is said to be in motion, and any object that do not change its position with respect to a stationary object and in reference to a time is at rest. So clear the two terms motion and rest. Anything that is changing its position with respect to a reference point, that is a stationary object, and time is said to be in motion, whereas the objects that are not changing their positions with the passage of time with respect to a reference point are at rest. Now let's discuss one more example, that is motion of a train for the same motion and rest. Now what do you see? A track, a railway track, some towers, electric poles, some buildings. Okay, these are electric poles, this is a building. All these are acting as stationary objects, and this train, it is one of the means of transport. So let's take it as a object that is moving. So supposedly this train was somewhere here, that means EP1. Okay, it is running on a track, a railway track. Any object that it counters by its side, which is a stationary object, we can take it as a reference point. Supposedly it was at this position EP1 at some time, and with the passage of time it reaches here. Okay, so our reference point was this electric pole 1, which was parallel to the train's engine. If the train shows any kind of movement and it crosses that pole and reaches any other point, we will conclude that the train is in the state of motion. and if not, if it is stationary at the same point parallel to EP1 with the passage of time, we will conclude that the train is at rest. So clear the two terms motion and rest with respect to these electric poles and passage of time. Remember, again and again I'm marking the same words, the reference points and time. These two constraints will decide whether the object is at motion or is at rest. Clear? Now, after having discussed various examples regarding rest and motion, let's come to its definition. How to define the two terms rest and motion. So, a body is said to be in a state of rest when its position does not change with respect to a reference point. Okay, and when is it said to be in motion? A body is said to be in a state of motion when its position changes with respect to a reference point. Now, let's discuss the various types of motions. The first one is linear motion, second one is circular motion, third one is oscillatory motion or vibratory motion, and the last one is rotational motion. Linear motion is anything which is traveling in a straight line is linear motion. We can simply take it as an athlete running on a track, a straight path. That is linear motion. Circular motion, anything which is traveling in a circular path. Oscillatory motion, anything which is repeating its path or is moving in a to and fro positions. This is mean position, this is to and fro. Okay, rotational, anything which is revolving or rotating on its own axis. For example, we can take it as a rotation of Earth. This is an example of circular motion. The boy is having a string tied to a stone and he is rotating it, and the stone is traveling in a circular path. Simply it is going through circular motion. The other example, satellites revolving round the earth, even the planets revolving round the sun. These all are the examples of circular motion. Okay. The next one is oscillatory motion. The example that I've taken over here is girl swinging. Okay, you can take it as a pendulum also. Pendulum also goes through a oscillatory movement. And for vibratory motion, you can take it as a strings of guitar. Strings of guitar. For rotational motion, the earth rotating on its own axis. Okay, this is the example of rotational motion. Revolution is example of circular motion. The pendulum one and this girl swinging is an example of oscillatory motion. Okay. So this was all about motion, rest. We discussed various examples for understanding the concept of motion and rest, and also we took up the types of motion. This was all a part of Introduction to Motion. Remember, the chapter has just started. It was mere introduction. The topics that we will be covering in the coming videos are scalar and vector quantity, distance and displacement, uniform and non-uniform motion, speed and velocity, accelerated and retarded motion, equations of motion, graphical representation of motion, and the last one, uniform circular motion. And also we will be discussing various numericals with the corresponding topics. Remember, it was just an introduction to motion. The topics are yet to come. Thank you guys. This was Dia Makhija from Bible Classes. I took up a chapter motion and just I finished up its introduction part. I'll be covering various other topics in my coming videos. For now, you can just read the chapter and can also mail me your queries if any at this ID makija_dia@yahoo.com. Have a good day guys and stay tuned.